Let's begin by asking, how do we measure something as simple as the length of a pencil or as complex as a DNA strand? In science, especially chemistry and physics, precise measurement of length is foundational. A standard tool is the meter rule, marked from 0 to 100 centimeters. These measurements are crucial. They feed into calculations of volume, density, pressure, and more. But just having a tool isn't enough. The accuracy of that tool, determined by its smallest division, decides how trustworthy our measurement is. The finer the division, the better our precision. Now let's explore how a meter rule is structured. It has 10 small divisions within every centimeter. That means the least count, or the smallest measurable length, is 1 millimeter, which is 0.1 centimeter. So, if an object lies between the 35 and 35.1 centimeter marks, we can safely say it measures 35.1. But what if the object's end falls between those marks? We hit the rule's limit, it cannot resolve finer details. This is why we say the least count limits the precision of your measurement. Here's where things get tricky. The meter rule, though simple and widely used, can't measure beyond the first decimal place in centimeters. It maxes out at 1 millimeter. If the edge of an object sits between two marks, we either round off, guess, or accept the inaccuracy. In chemistry, this may not matter for rough measurements, but in analytical work or physics experiments, such imprecision is unacceptable. To overcome this, we turn to more advanced tools designed for micrometer level accuracy. Enter the Vernier calipers and screw gauge, the heroes of high precision measurement. Vernier calipers come with an extra sliding scale, the Vernier, that lets you read lengths up to 0.01 centimeter. For even more precision, the screw gauge operates on rotational threads, letting you measure up to 10 micrometers or 0.001 centimeter. These instruments are essential in research labs, engineering, and even medical device manufacturing. And remember, the smaller the least count, the more accurate your result. Let's connect this to the real world. In a physics lab, you may need to measure the thickness of a wire with accuracy down to micrometers. That's where the screw gauge comes in. In chemistry, volumetric glassware and test tube sizes rely on precise lengths for correct readings. Engineers building mobile phones and doctors designing stents all require measurements that are precise down to the smallest units. Using the right instrument avoids costly errors and brings science into perfect alignment with reality. Let's wrap up with a quick summary. A meter rule is great for everyday use, giving you accuracy up to 1 millimeter. But for finer measurements, Vernier calipers and screw gauges are essential. They allow us to go further, into hundredths or even thousandths of a centimeter. Remember, the lower the least count, the higher the precision. And in science, where tiny differences can make a big impact, choosing the right measuring tool is just as important as using it.